total around 50 students are joined now. Uh, so yesterday, Ruchika has faced the problem. Is there a Ruchika in the classroom? Yes, Ruchika, can you hear me? Yes, okay, she's there. Okay, so yesterday we discussed about the syllabus and the different topics that are included in your syllabus, computer organization and architecture. So, can anyone like Prathamesh? Prathamesh, can you hear me? Prathamesh, yes, Prathamesh, or any other. Can you mention? Anyone can tell what are the topics we discussed yesterday? Abhishek, Abhishek Gowli, or you can mention in the chat box also. You can mention in the chat box what are the topics that we discussed yesterday, the concepts. So yes, Prathamesh. Okay, Prathamesh is not
Hello,
there.
sir. Hello.
Prathamesh. Okay,
Sir. Some network problem is there,
okay,
sir.
okay.
So yesterday we have discussed the introduction to our computer organization and architecture. Means we have seen the basic difference between computer organization and architecture.
Okay.
Means how the computer system is built and how it is organized. It is studied in organization section, and its internal structures and all these things are discussed in computer architecture.
Okay.
And
Okay.
we have seen the history of computer, that is first generation computer, second generation computer. Means how the technology is improving till now date. We have seen means old devices, means where the computing is done. These devices we have seen, sir.
Okay. So computer organization is concerned with how the different components of the computer are connected, and computer architecture means the structure of the computer. Okay. So some people are facing the problem, but see, there is no problem from the my side. Uh, just inform those who are. You can inform them to join because already 50 students are joined, so I think there is no problem. And also in Google Meet there is no limit also. I think more than 100 people they can join in the Google Meet. Okay, we'll start with the. Yes, is my slide visible? And I am recording the video, so if someone is missed the session, so I will provide the. mm, what's her name? Someone facing a problem. Yeah, I'm not getting any request. I think you people can see my screen, right? Some students are facing the login problem, but I'm not getting any request from the students, and it is auto. Let me check. Uh, okay. Okay. So is my screen visible? Say anyone yes,
Yes,
guys.
sir.
Okay. So I think is that the people they joined? Okay, you are not able to join. I think maybe some technical problem. Okay, I will provide the this video later. I'm recording the session. So today we'll discuss about the von Neumann model. The von Neumann model. This is a very important model because uh, this von Neumann model that consists of five major components: uh, input unit, output unit, arithmetic logic unit, memory unit, and control unit. So this von Neumann model, von Neumann means the computer is based upon this concept. The computer is having a input device, output device, arithmetic logic unit to perform the operation, to perform the ALU operation, and a memory unit to store the data, and control unit to control the operation. So the von Neumann model. So this is the all the computers are based upon the this model, and it's a very important model for the development of the computer. Okay, so simple, the present computer or whatever the devices that you are using, and all that devices, mobile devices, that is based upon the von Neumann model concept. Just uh, just remember what is the von Neumann model. Von Neumann model means it is having input device, output device, ALU, memory unit, and control unit. Means these units are required for the for computer. These all the units are required for the computers. The system bus model. System bus model, a refinement of the von Neumann model. The system bus model has a CPU, that is a combination of ALU and control unit, memory, and IO unit. So system bus model means it is having a combination of the CPU. CPU means it is a ALU and control unit, ALU and control unit. This is one CPU, then memory, CPU, memory unit, and IO unit. IO unit. So this is the uh, system bus model. System bus model, and here the main is that the communication among all these models are handled by the shared pathway called as system bus. The communication among the different units. So in one Newman model is that the different units, the ALU is separate, input output is separate, memory is separate, control unit is separate. So the system bus model is the extension, is a refinement of the one Newman model, but the same, the everything is same, like the CPUs. The CPU is the one unit, but CPU that consists of ALU and control unit, ALU and arithmetic and logical operation and control unit. So what we can say, your CPU, central processing unit, that consists of the different hardware like motherboard, CPU, motherboard, processor, motherboard. Then what is that processor? As just I'm giving just a rough idea. Processor, and there are some capacitors, resistors, then some socket cords. I think you are getting some idea what is CPU. CPU means and all these are connected by the soldering. These different units are connected. Soldering means the control signals that control the operation. These different uh, the units are connected to each other. So this is the processor like. So a CPU means central processing unit. That CPU is a combination of ALU and control unit, memory, and input output. So communication among the components is handled by the shared pathway called as system bus, which is made up of data bus and address bus and the control bus. So there is also a power bus, and some architecture may also have a separate input output bus. So this is the architecture. The architecture means how the computer looks. Computer means it should have the input unit, output unit, memory, ALU, and control units. So this is the diagram for the system bus. System bus means how this is the diagram how this is one unit CPU, memory, then input output units. So all these three units are shared, exchanging the data, exchanging the CPU from CPU to here memory, exchanging the data, and the control bus that control the operations. So this is called as the system bus. System bus means it includes the data bus, address bus, and control bus. Data bus, address bus, and control bus, and control bus. And suppose if I'm not audible at any time, so you can, because my screen is in the full screen mode, so I can't see the chat box. If you are any problem, just to interrupt me in the middle. Then we'll discuss about the uh, levels of machine. So levels of machine. So just we'll discuss two concepts. One is one Newman model, that is having the different units. In the system bus model, the CPU that consists of the ALU registers and control units, memory, and input output, and these units are controlled by the system bus. System bus means the data bus, address bus, and control bus. Then levels of machine. Levels of machine. So this is the diagram for the levels of machine. The levels of machine, that is from how we view the computer, how we view the computer, the levels, user level, that is application program that we use as a end user, use the any softwares, any applications, that is user level, to transistors and wires. So just imagine that you are using any application in your mobile device or any computer, so that is a higher level. And the lowest level is that the hardware component, the transistors, wires, the chip, the small processors. So that is the low level. So the levels of machine, there are number of levels in a computer. There are number of levels in a computer, from the user level down to the transistor level. The levels of machine means the layer, how we view the computer. The processing from the top level means the user level, the user who is using the computer, the user who is using the applications. So processing from the top level downward, the level becomes less abstract as more of internal structures of the computer becomes visible. Means how we go downwards, the the internal structure of the computer becomes visible. So how for example, like the down level means we can go for like your your transistors, then the number of transistors that becomes the ICs, integrated circuits. I think you people know that. If there are thousands ICs means like your processor IC is also one of the, it's a processor. So your IC, I think you in logic design you have used I think 16 pin IC, 14 pin IC, I think 14 pin IC, like 7400 NAND gate, 7408 AND gate. So such IC means that is a collection of transistors. So this is the low level. So this is the one more level up transistors. So likewise, then the processor means the again the is a collection of IC we can say, or the large number of transistors. So one of the reason for enormous success of digital computer is the extent to which these levels of abstractions are separate or independent from the one another. So here, how you can see, uh, how we can see the levels of computers. Like for example, the user is user level application programs. So user interacts with the application programs. He won't see the inner details. Just in the computer screen, he use the application. So even if you go in depth, the high level programming languages, high level the high level programming languages are used to develop the softwares. Then assembly languages that converts the assembly language into machine code, assemblers, then hardwired control means how the hardware's components are connected and how these are controlled by the control signals. Then different functional units, memory units, different units, how they are connected. Then logic gates, and then last are the transistors and wires. So these are the different levels, So how much we go in depth in low level, so we can understand the internal structure of the computer. So the extent to which these levels of abstractions are separate and independent, so that is the success, because once we know the computer architecture and all, and we can do the improvisation, we can upgrade the hardware components. So in the market, you can see nowadays, in every month or in every year or in every 6 months, we are getting a new model in the market. The changes in the architecture, maybe the change in the hardware. I mean the all the devices they're improvising in terms of power consumption, in terms of performance, in terms of their efficiency. So we are getting a new model and with low cost. So that is also one of the, all this because of the advancement in the semiconductor technology. Okay. Then so this is about the levels of machine from user level to the low level, that is a transistor or wires. Then upward compatibility, the invention of transistors that led to the rapid development of the computer hardware. So as the invention, the transistor counts, the transistor that led to the rapid development of the computer hardware, and the with this development came a problem of compatibility, because as the in the market, as large number of transistors are available, and many companies they came forward to develop the computers. So like Dell, IBM, different the companies they came forward for developing the computer. HP, Acer, so you can see LG, the different companies they came to the market, and they started to development of computers and faced the problem of compatibility. Faced the problem of compatibility. So each new computer model had a new architecture and old software that would run on the new computer. Means old software it would not run on the new hardware, because the computer hardware that is manufactured by the different companies, and software is designed by the different companies. So there was that problem we faced in the 1950 1960. But nowadays there is no such problem, that compatibility problem. So upward compatibility that allows a user to upgrade to a faster. So to survive in the market nowadays, the there is a compatibility in the software and hardware, because they need to do the research, and they have to develop a compatibility softwares and hardwares. So this is about the user level, as we already discussed. User level, the highest level, user interacts with the computer by running the programs such as the word processor, spreadsheets, and means the user. So this is the high level. High level is the user level. User level he interacts with the software applications. And high level languages like C, Java, Pascal has interacted with the computer at this level. And at this level, the programmer sees the data types, instructions of the high level language, but needs no knowledge of how these data types are actually implemented in the machine. So the second level, high level language, means how level of language, the high level language that interact with the software. Then assembly language, assembly language, the compiler that translates the source code into the machine code. That machine code that is understood by the machines. Then control levels, control means control units, that we can say hard wiring. The control unit that interrupts the machine instructions one by one, causing the specified register transfer or any action to occur. So hardwired control unit have the advantage of speed and component count. So control unit is a very important role, because just I can give one example for control unit, so suppose it is an accumulator, say accumulator, A register, and some, like for example, B register, C register. Suppose to perform the operation from taking the value from B and C and store the result in accumulator. Here the control signal will perform the operation. Control signal that read the data from these registers and store the result in accumulator. So that control unit operation is very important. So how the brain works in human body, how the brain works, how we control the thoughts. So in the similar way, control operation, that is by the control unit. Then functional unit level, so register transfer is implemented by the control unit, move the data in and data out. The functional unit, it includes the internal registers, ALU and memory, the different functional units. Then at the last, logic gates, transistors and wires. It's the very lowest level of the computer. So, so we are getting, so here with the changes, the transistors, as now nowadays the modern computers that is having the billions of transistors in our processor. The i5, i7, the billions of transistors. As we compare with our 8086 or 8085 processor, 8085, 8085 that consists of around 10,000 transistors, and just you compare with i5 or i7 processor, so how the transistor count is increased. So this is the typical computer system. So that having the motherboard, the CPU, hard disk, the monitor, keyboard. So you already know all these things. And Manchester Mark One. So that is the first computer, the Manchester Mark One, that's showing that they called as Manchester Baby. It was the first computer, ENIAC. So before naming the ENIAC, ENI ENIAC, they called it a Manchester Mark One computer. So this is the computer, the Manchester Mark One, the first computer, Manchester, the first computer. So you can see the units in it is like a rack. The rack, they are placed in a room. So I have one video that I will show you. Uh, the history of. So is my screen visible? So anyone? Yes.
Yes, sir.
Okay. You just go through the 2 minutes. So you go through the first computer, the ENIAC computer, the full version. Okay. So I this the downloaded from the YouTube.
Sir, can you increase the volume, please?
Okay. I think maybe some problem is the actually I'm using the microphone, the headphone. So you just go through the visuals. Okay.
University of Pennsylvania. They headed up a team of engineers and others that worked on the ENIAC project, which began in 1943. The team that worked on the ENIAC included a large number of women who were instrumental in the detailed task of manually programming this giant machine. Programming was accomplished by setting switches and connecting wires according to specific instructions, which were first worked out on paper and then carefully carried out and tested. Mapping the program out on paper took weeks. The task of setting the switches and wiring cables to match the program diagram then took many days to complete. When it was originally designed, there was no written manual on how to program the ENIAC. The women involved in the actual programming of the machine relied on block diagrams and logic diagrams of the machine's operation, as well as personal talks with the engineers directly responsible for specific parts of the ENIAC machine. In 1997, the 6 women who did most of the programming of ENIAC were inducted into the Women in Technology International Hall of Fame. In addition to switch panels and wiring panels, ENIAC used an IBM punch card reader for input and an IBM card punch machine for data output. The timing of these machines was synchronized with the operation of the ENIAC itself. The ENIAC was a very large machine. It weighed over 30 tons. The ENIAC had a total of 40 panels and utilized 18,000 vacuum tubes, with 70,000 resistors and 10,000 capacitors. ENIAC also had its own dedicated power lines. To keep the vacuum tubes from overheating, the room was air-cooled. When ENIAC was announced in 1946, the news media called it a giant brain. Its computing speed was 1,000 times greater than that of electromechanical machines. This computational power, along with its general-purpose programmability, made it a technical marvel of its time. ENIAC's design and construction was financed by the United States Army. The construction contract was signed on June 5, 1943, and work on the computer began the following month. The cost of the ENIAC in 1946 was just under $500,000, which is equivalent to over $6 million today. ENIAC was formally accepted by the U.S. Army in July 1946. ENIAC was temporarily shut down on November 9, 1946, for a refurbishment and a memory upgrade. It was then transferred to Aberdeen Proving Ground, Maryland, in 1947. There, on July 29, 1947, it was turned on and remained in continuous operation until it was powered down on October 2, 1955. ENIAC was initially designed to calculate artillery firing tables for the United States Army's Ballistic Research Laboratory. A typical ballistics calculation that previously might have taken 12 hours using a desktop mechanical calculator could now be done in just 30 seconds. The ENIAC's other applications included weather prediction, atomic energy calculations, cosmic ray studies, thermal ignition, random number studies, wind tunnel design, and other scientific uses. Here, output from one of ENIAC's printers is being produced. In this scene, we see brilliant ENIAC designers J. Presper Eckert on the left and John Mockley on the right. They would continue their involvement in computer design and manufacture far beyond ENIAC in the years to come. Even before ENIAC was fully operational, both Eckert and Mockley realized they could design and build a significantly more capable and efficient computer, incorporating some design improvements. They began working on a computer they called the EDVAC. EDVAC was delivered to the U.S. Army's Ballistics Research Laboratory in 1949 and made fully operational by 1951. In 1946, the University of Pennsylvania adopted a new patent policy, which would have required Eckert and Mauchly to assign all their patents to the university if they stayed beyond March. Unable to reach agreement with the university, both Eckert and Mauchly left the Morse School in March 1946, along with many of the senior engineering staff. Soon afterwards, Eckert and Mauchly started up the Electronic Control Company. They later changed the name to the Eckert-Mauchly Computer Corporation, or EMCC. By October 9, 1947, they had a contract with Northrop Aircraft to build the BINAC, or Binary Automatic Computer. EMCC was officially incorporated. Wilmington Sperry merged with Burroughs in California.
So I'm getting some problem in the taking the attendance. So I will take the screenshot. Otherwise, it is anyway the session is recording. So I'll just note the numbers, the roll number, and your name. Okay. So this is about the history of computers, von Neumann model, and ENIAC, the first computer. Okay. So next we'll discuss about the generations of computers. Generations of computers. So tomorrow while coming to the for tomorrow's or Monday lecture or next lecture, you just go through the generations of computer. Am I audible? Yes, guys.
Yes, sir.
Okay. Generations of computer. You just Google it. The generations of computer. So this is very important for your examination point of view. The different generation, first generation computers. So whatever the video just now we seen, the ENIAC, the computer that comes in the first generation computers. So second generation is having transistors. In the first generation, vacuum tubes were used as a processing device, vacuum tubes. And in the second generation, transistors are used. Vacuum tubes are replaced by the transistors. Then in the third generation, the transistors are replaced by the integrated circuits. ICs are used as a processing device. And in the fourth generation, processors are used. In the Intel family, they started to develop the processor fourth generation. And in the fifth generation, artificial intelligence, machine learning, that all the concepts that along with the processor, these machine learning, AI, robotics. So that all the concepts that came in the fifth generation. I think you got some idea. So first generation means vacuum tubes were used as a processing device. In the second generation, vacuum tubes are replaced and the size of the computer is reduced. So the second generation computers, the main processing device is transistors. As you know, transistor size is small compared to the vacuum tubes. Vacuum tubes means it's like a bulb. In the yesterday I shown, it's like a bulb, the large structure bulbs. Then transistors are replaced by the ICs, integrated circuits, that you are, I think you people are used already in the laboratory, ICs. Then ICs are replaced by the processors. In your laptop or you have seen the processors, a small chip that contains the around 48, 40, 40, 45, 40 pin that processor. It is contains the large number of transistors. Then in the fifth generation, we are using the AI and all for development of the computer. So you can see in your mobile device only you will provide the security through your thumb, the fingerprint, eye recognition. So these are all because of AI techniques. Sometimes it scans your face to uh, as a security you can keep in your mobile. So that all comes in the generations of computers. So in the next class we'll discuss about in detail. So before coming to the class, so what do? You just go through the you go through the your uh, that particular generations of computers. So any doubt? So you can mention in the chat.